Have you ever really looked at the world around you? I mean, really looked. The screen you're watching this on, the door to your room, maybe even a book on your shelf. They all have something in common. They're all part of a huge secret family of shapes called quadrilaterals. And today, we're going to pull back the curtain and uncover their hidden rules, their relationships, and we'll start with a puzzle that builders have been solving for centuries. So we're not starting in a math textbook. We're starting on a construction site with a really practical problem. It's a challenge that carpenters and builders have faced forever. How do you make absolutely sure that the corners you're building are perfectly square? So here's the puzzle. Imagine a carpenter with just two thin strips of wood. These are going to become the diagonals, the lines that cross through the middle of our shape. How can she join them together to guarantee 100% that she ends up with a perfect rectangle? Okay, before we solve this, let's just quickly remember what a rectangle even is. It has two non-negotiable rules. One, all four of its corners have to be perfect 90-degree right angles. And two, its opposite sides have to be the exact same length. That's the goal. And the solution? It's actually incredibly elegant and simple. There are just two conditions you have to meet. First, those two wooden strips, our diagonals, they have to be the exact same length. And second, they have to cross each other at their precise midpoint. Or, to use the fancy math term, they have to bisect each other. You do those two things, you get a perfect rectangle. Every single time. And this isn't just some abstract idea from a geometry class. This is real-world stuff. As this quote points out, carpenters in Europe use this method. Farmers in Mozambique use this method while constructing houses. It's a universal trick that works anywhere, from a high-tech workshop to a farm, because the geometry is always true. Okay, so we've totally mastered the rectangle. But what if we want to level up? What if we want to build the most perfect, the most symmetrical four-sided shape there is? The square. Think about it. We already know the secret to making a rectangle. The diagonals have to be the same length and they have to cut each other in half. But that's not enough for a square. So what's the one extra ingredient, the one magic step we're missing? And here it is. The secret is the angle where those diagonals cross. For a square, they still have to be equal. They still have to bisect each other. But they also have to intersect at a perfect 90-degree right angle. That one extra rule, that changes everything. And that one simple tweak, making the diagonals perpendicular, it causes this incredible domino effect. Suddenly, it's not just opposite sides that are equal. All four sides snap to the same length. All the corners are perfect right angles, of course. And get this, the diagonals now slice each of those 90-degree corners into two perfect 45-degree angles. So cool. All right, let's pull the camera back for a second. We've been focused on these very specific, perfect shapes. But what about all the other four-sided shapes out there? Well, it turns out there's one simple, beautiful rule that connects every single one of them, no matter how weird they look. Here's the key insight. You can take any quadrilateral, I don't care how lopsided or strange it is, and you can always draw a line from one corner to the opposite one, and boom, you've split it perfectly into two triangles. And if you remember one thing from math class, it's probably the golden rule of triangles. Their three inside angles always add up to 180 degrees. So if every single quadrilateral is just two triangles stuck together, well, the math is pretty straightforward, right? Yup, 360 degrees. Always. It doesn't matter if it's a perfect square or the most bizarre, stretched out shape you can imagine. The four angles on the inside will always add up to 360. It's like a universal law of the shape universe. Okay, so we've got our core rules down. Now the fun begins. We can actually discover the rest of the quadrilateral family just by playing a game of what if. What if we start to relax some of those super strict rules we had for our squares and rectangles? For instance, what if we forget about the whole 90-degree angle requirement? What if our only rule is that the opposite sides have to be parallel to each other? Well, if you do that, you get a parallelogram. Just picture a rectangle that someone gently pushed over. And parallelograms have their own set of cool properties. Their opposite sides are equal, their opposite angles are equal, and just like our rectangle, their diagonals bisect each other. So this tells us something important about the family. Every single rectangle is a type of parallelogram, but not all parallelograms get to be rectangles. Okay, let's play what if again. This time, what if the only thing we care about is that all four sides are the exact same length? We'll let the angles be whatever they want. Well, that gives us a rhombus, which you probably know better as a diamond shape. And here's where the family connections get really interesting. Because a rhombus has 4 equal sides, it turns out that its opposite sides are automatically parallel. And what do we call a shape with parallel opposite sides? A parallelogram. So that means every rhombus is also a special kind of parallelogram. See how they're all related? Now, let's meet a couple more cousins in the family. First up, the kite. Now, for this shape, the rule changes. It's not about opposite sides being equal, it's about adjacent sides, the ones right next to each other. A kite has 2 pairs of equal sides that meet at the corners. Yep, just like the kind you fly in the park. And we can't forget about the trapezoid or trapezium. Its whole deal is that it has just 1 pair of parallel sides. Think of it like a triangle with the top chopped off. So we've met all the key family members: the rectangle, the square, the parallelogram, the rhombus, the kite, the trapezoid. Now it's time to put it all together. Let's see the official quadrilateral family tree. So here's an easy way to think about it. Parallelograms is like the main family name. Under that big umbrella, you've got 2 major branches: the rectangles, which are parallelograms with perfect 90-degree angles, and the rhombuses, which are parallelograms with 4 equal sides. And the square? The square is the special kid who inherited traits from both sides of the family. It's got the right angles of a rectangle and the equal sides of a rhombus. And this Venn diagram, this just makes it all crystal clear. That big outer shape represents all the parallelograms. Inside, you've got the circle for rectangles and the circle for rhombuses. And see that little section right in the middle where they overlap? That's the square. It proves visually that every single square is also a rectangle and a rhombus, which makes it the most exclusive member of the family. So there you have it. The family's secrets are out. You know what makes a square special, you know how it's related to a rhombus, and you know the one rule that connects them all. So here's your challenge. Go on a shape hunt. Maybe grab some rubber bands and a geoboard and try to build a trapezoid, or just fold a piece of paper into a kite. Now that you know their secrets, how many different quadrilaterals can you spot hiding in plain sight all around you?